Hi, everybody. Hope you're doing well. It is Friday, dinner time. Last thing on my list today was to offer you a little teaching on what we call air pollution. So, we've studied climate change a lot related to carbon in the atmosphere, correct? And now let's try to link all the other issues related to air pollution. They really have a direct impact on human health. And I know in our lecture this week, we studied the city of Mexico City and how all these air pollutants play out to create this thing that's called smog. Smog is that smoky like vapor found in many cities around the world that has a direct impact on human health from infants all the way to elderly, and we can look at that. So first step really is to really understand and identify what these things are inside smog. So we're going to call these the major air pollutants. Major air pollutants. And first one is going to be what we call nitrogen oxide. Nitrogen oxide is primarily emitted when fuels are burned like gasoline. So the gasoline in your car, in a bus, and so on, when that liquid is ignited, it's going to release nitrogen. There are things in cars called catalytic converters that actually take nitrogen and do some really tweaky chemistry to create non-nitrogen emissions like CO2 and water, which is good. Nonetheless, this is a material that's emitted all over the world. It also is going to relate to something called nitric acid. Nitric acid, which we know is a large component of something called acid rain. So that clearly is problematic. Now, what else can these type of things do? They can actually result in lung irritation and damage. It can suppress plant growth. And there are links to say that it can cause that disease we call cancer. Okay? And you're probably going to see that theme over and over, likely more to do with lung cancer. Another related compound is sulfur oxide. And sulfur oxide, slightly different, mostly emitted from the burning of coal and oil. However, similar thing, acids are created, and it again has a link to the health of humans, all right? And that's a real issue, and it damages the environment for sure. And it, can cause breathing difficulties and productivity, plants go down, and so on. Third one is, I think, rather interesting because it sort of has a dual role, a good and a bad. And these are it's called ozone. Now, ozone way up in the stratosphere has been created ages ago by plants, actually. What they emit is oxygen. Ozone built up in the atmosphere, and what it does is it blocks harmful UV radiation, which damages cells. So you think of people get skin cancer. Ozone in the atmosphere actually acts as a blocking for that. And so it's cellular life on Earth doesn't get as damaged. However, these components are actually made when the smog reaction occurs, we'll look at later. Ozone is actually created from that by sunlight hitting nitrogen oxide, so we take that NOx through different nitrogen forms. When sun hits that, O3 is created. Big deal, right? Well, it is a big deal. This is related to lung cancer, lung irritation, lung damage, bronchial constriction, clearly a factor if people have asthma. So if someone's an asthmatic, perhaps you are, about 25% of the population of the city has asthma. Those people are clearly more at risk for being damaged by this and exacerbating their problem. Coughing, wheezing, eye irritation, plant damaging, rubber damage, plastics. very corrosive stuff. Okay, number 4 is called PANS. Now, PANS has a very, very long name. So perioxyA cetyl nitrate. PANS. Now, these are also secondary, that are caused when oxygen and nitrogen are sort of mixed by ultraviolet radiation, in fact, to be created. Unfortunately, these are unstable, and they're often found in urban and industrial pollution. And what can happen with these cause eye irritation, and linked also to extensive damage to vegetation. And lastly, I think, or actually, sorry, you have 2 more, my bad. There is what are called particulate matter. Now, particulate matter, they often put a number here, and that's related to the size of the particle. So, for example, this size of a PM of 10 are particles with a diameter, it's about how you say, a seventh of the width of a human hair. So imagine you took the strand of your hair. Here's my hair. Somewhere. There's my hair. I don't know if you can see that. But take the seventh of that, just in terms of width. That is the size of it. So the 10 refers to micrometers or micrometers. Well, these materials, maybe they're invisible. Sometimes they're seen when they're in higher concentrations. Think of something like smoke. When we see smoke, that is a particulate matter. Dust is a particulate matter. Imagine a bus that goes to leave a stop and it spits out all this black smoke. Diesel soot, it's called, that is as well. These often contain lead, Pb, and they can also, some of them are made of what's called asbestos. Asbestos, it was a more common compound used in building materials back in the day, and asbestos was how you put a fire retardant. So it was used because if a fire occurred, it tended to be able to withstand fire and slow it. However, it was found later on that this becomes a particulate matter, and it causes a disease called asbestosis, and that is a clear lung damaging disease. More to look at. When 9/11 occurred, for example, the Twin Towers fell, there's a lot of asbestos in the air, and that actually became a relatively common disease found among the people that stuck around after to do the cleanup. Not cool. Anyway, that is a reality, and again, these are found all over the world, unfortunately. One more are called VOCs, or volatile organic compounds. So volatile, what does volatile mean? So volatile is sort of like, if something's volatile, it's very reactive. So imagine these protests now, the people are volatile, or maybe the police are very volatile, they're very reactive, what's going on. So volatile organics, or VOCs, these tend to be compounds, when they are in the atmosphere, they tend to react with other things and create new monsters or create new poisons. That's the story. Preservatives, liquid preservatives, benzene, acetone. Acetone you might be familiar with if you use nail polish remover. That material is an acetone. It's very destructive. That's just one example out of many. These, often an indicator is they tend to be like a fume, like an aerosol, or when you open up a bottle of something, it like immediately odor appears. Paints, aerosol sprays, dry cleaning fluids, industrial solvents. All these are lung irritants, and they can damage the lung material and again cause that disease of cancer. Now, unfortunately, this goes beyond just lung cancer. These tend to relate to liver, kidney, and even some form of nervous system damage. So these are really, really problematic. Okay, so as we said, smog earlier tends to be a mixture of these compounds. And we're going to look now is really one of the prime ones in this is nitrogen. So in our next video, I'm going to show you basically the story of smog and how that works. See you then.